All right. Getting that pulled up. Perfect. All right. Up next, we have Mark Subbarao, who is the director of NASA's Scientific Visualization Studio. So they're the group that creates a lot of the visualizations that we see on this beautiful hyperwall here. So welcome, Mark.
All right. Thanks, Steve. You know what? I was sitting up there. It's tiring. Come and take a seat, right? Like, we have some seats up in front. So what I'd like to do is maybe a little bit differently. You've seen a bunch of speakers, and they've been showing you lots of visuals. A lot of that's produced by my group, the Scientific Visualization Studio. So what I'd like to do is maybe along the way we'll talk about some of the science, but I just want to show you some of our recent work and make the following point. All of this is freely available to everyone, not just NASA leadership. It's all available for everyone to use and reuse in any way they want. And in many cases, we'll have links to that. One of the big efforts for our group over the past year has something called the Earth Information Center. And so that is both a physical exhibit. That exhibit is at NASA headquarters in Washington, D.C. We're soon going to open up another physical exhibit at the Smithsonian Natural History Museum. And then next year, some more physical exhibits as well. But it's also a virtual exhibit. You can go to the website now. We've actually just got a new website, and that's on earth.gov. So if you go to earth.gov, you can check that out. And in the physical exhibit, we have a version this is mocking up a little bit of what exists on that physical exhibit, but a number of live feeds. The idea is to create a snapshot of like all the information that NASA is collecting about our planet. And we'll do that in different themes. This is a current theme just about what's available now. So we see live satellite observations from NASA Worldview. We also see information from the Earth Information Center partner agencies. So many other federal agencies are partners, including NOAA. So we see some information from the NOAA satellites. This is another NASA communications product, which you can check out back there, Eyes on Earth. And also we have our climate site, so the climate vital signs. So all these things are being pulled live. The Earth Observatory as well, which is feeding us an image of the day. So here's some shots of the facility in Washington, D.C., and this is being used for a number of different groups, but often to talk to policymakers. So here you see the Prime Minister of Mongolia visiting. One of the things we're able to do is show some of the NASA data that's being used to help actually the cashmere industry in Mongolia, and they were very excited to see NASA data about Mongolia. This is a shot from a really special day as well. We brought in a group of indigenous Amazonian leaders, and they got to visit the Earth Information Center. And they are all using NASA data to help protect their forest. But we also got to hear from each of them as they talked about how they're directly experiencing climate change. Heard stories, amazing stories, like this gentleman over here. When he was speaking, he said, "We know that the climate is changing. We feel it. The fish are dying. The fish even taste different." That's one thing that he said. So really, really great conversation. So we built this space, and it's working as it was intended to be a convening area to bring people together, to surround them physically with the data, but actually just to provide a venue to start those conversations. One of the big things that we had to innovate to get ready for this Earth Information Center was to not just create visuals for a big conference. Like every year for AGU, we make new things. I'm going to show you some of the latest things we made for this AGU. But to make sure we're keeping those fresh and up to date. So what you're seeing a number of models of air quality coming from the Goddard Modeling and Assimilation Office, and these visualizations are being updated every single day. So you can get a visualization of the last 2 weeks, and every single night that's being updated. It's updated on this display, but it's available to you as well. The Earth Information Center covers 9 themes. One of those themes is greenhouse gases. So here you see some of the visualizations about greenhouse gases. We include, again, data from our partner agencies, in this case NOAA, where we get data about nitrous oxide and methane. Here you're seeing a comparison of global satellite measures from NASA of carbon dioxide compared to the Mauna Loa Observatory. Of course, the Mauna Loa Observatory has a much longer run, but you see they line up very nicely. Because one's global and one's at a specific spot, the seasonal variations are different, but we also hear models of methane and carbon dioxide as well. And one of the other themes is air quality as well, which I mentioned before. So if you were here earlier, you saw Karen St. Germain talking about the Tempo satellite. So we've got much higher resolution, both spatially and temporally with Tempo. And here you see a zoom in over Chicago. And now with measurements that are roughly hourly, although the cadence varies, you can actually see how air pollution varies during the day. You can see the effect of rush hour. You can see it go down. You can see it pick up again in the evening rush hour as well. And if you look carefully, you'll see that pattern over Chicago. All right. Let me show you, let me zoom in on a couple of those visualizations and spend a little bit more time with them. So here you're looking at 2 volumetric models of a year of carbon dioxide. So 3-dimensional model of, in this case, of the year 2021 and what happens over that year. So right now we're in March. You're going to see both the seasonal patterns and you're going to see diurnal patterns as well. You see both are experiencing the same weather. So you'll see similarities, but if you look carefully, you can see some differences in where that emission's happening. For example, with methane, we're seeing emissions from wetlands. Now we can break that down a little bit further, and this is an example using some of our partner agency data. So this is one of the EIC partners, the EPA's methane inventory, and we can break down, at least over the United States, methane emissions by sector. So agriculture we saw, which was most of, but coal, oil, gas, and there are all the emissions together. So let me play that through one more time. So the biggest slice of the pie is agriculture, but it's well spread out across the country. Emissions from landfills mostly. Natural gas, you can see the infrastructure of roads, pipeline, leakage along pipelines. Oil. And coal. Coal, active and both abandoned coal. All right, here's one of our more involved visualizations. This is, again, another visualization, volumetric visualization of carbon dioxide. But in this case, we're breaking it down. We're tagging it according to its source. So does it come from fossil fuels? That's the yellow we're seeing. Is it from the burning of biomass? That's a deep red, which you'll see a little bit of off the coast of Africa, say. the ocean or the land. And we also see their absorption, and those are little dots. So green is where the land is absorbing CO2. Blue is where the ocean is absorbing. And this diagram is an accounting. Again, we're showing a full year. Right now, we're in June. You see at this point, we're actually carbon negative. The land has absorbed more than we've emitted with the help of the ocean. You can see the predominance of the northern hemisphere fossil fuel emissions, where obviously most of the people, most of the land are. But now we're getting into fall, and we'll start to see as we get deeper in the season that actually the northern hemisphere biosphere will begin to die off, and we'll see that move up. And by the time we get to the end of the year, we're going to wind up about 2 parts per million higher than we were at the start. All right, this is slowed down because we had all right. There we go. So now we've reached the end. And hot off the presses, actually this one isn't quite on the presses yet, so I'm giving you a preview that we haven't, model we haven't released yet, but this was mentioned in one of the talks. So this is the new higher resolution models of carbon dioxide. We're now down to 3 kilometer resolution. Visualizing this was quite a challenge, the amount of data involved. So here you're seeing global patterns. We're looking at about 40 days in February. You see the diurnal cycle. You see the forests of Africa emitting during the night, but they're absorbing more than they're emitting, and Amazon as well. But really the power of the 3 kilometer data is it allows you to zoom in and see individual objects. So let's now zoom in a little bit to the United States. And now we're getting to the point where we can actually see emissions from individual power plants. Hi. And you can see the individual plumes coming off. You can see them swirling around with the weather. Yeah, let's watch that again. So like I said, this one is fresh off the presses. In fact, right now, as we speak, we're rendering a third sequence where we fly through it. Actually, it takes a long time, so like we have computers running right now. But fly through and get a 3-dimensional view of it. So sometimes data visualization is about that kind of problem. It's taking really big data and trying to make it simple, make it something visual that you can understand. Sometimes it's the opposite thing. We're taking a simple piece of data and we want to make it interesting, visually interesting. And that's what you're seeing here. So this is the climate spiral. And, well, this year has just been out of control. Like, you all know that, right? And you can tell people that. But part of, I think, our job is finding ways to make people feel that, to really feel how just insane the temperatures this year have been. So as you can see pretty clearly, since June, we've been breaking a record every single month. And not just by a little bit, by a lot. Yeah, see it sticking out there? Sorry. And this is another example of that kind of visualization. So in this case, we were trying to visualize NASA's satellite record of sea level change. So over about a 30-year record, 30 years, we've been able to observe about a 4-inch change rise in sea level. I can show that to you with a plot, but in this case, what we did in the Earth Information Center where this was created, this actually sits in sort of a circular porthole, so it looks like you're looking out a submarine window, and this is actually scaled so that on that display 1 inch is 1 inch, and you can just watch over time. And so, it's probably, if you just want to read the data, a plot's more is better, but people aren't going to share a graph millions of times on social media, right? So that's the point of making something like this. Oh, I get impatient. All right, here's another visualization from earlier in this year, showing a result coming from the GRACE satellites, and it's showing that both droughts and extremely wet events, pluvials, are becoming more common over time. Not only are they becoming more common, but they're becoming more intense. So we're representing wet events as water and kind of shiny water, and the brownish events as droughts. And the size of the sphere represents the intensity, which really relates to the volume of water or lack of water. So you can see both of those increasing over time. Again, I mentioned earlier, but one thing I encourage you to check out on our website is we now have a gallery of visualizations that are updated daily. And currently we have about 25 things that are updated daily, another handful of things that are updated monthly. This is one of those daily visualizations. It shows polar sea ice. This is coming from JAXA data. So again, we work visualize data that goes beyond NASA data. And of course, as you all know, this year in particular, as we get up to 2023, it's been a record-setting year in the Antarctic, record low sea ice. All right, so this is a visualization that was released on, hey Jason, that was released on our website today. So this is a space weather visualization. We're visualizing actually a pretty mild coronal mass ejection that occurred in February, March, I can't quite remember, of 2022. And this one was notable because of its effect, and it caused 38 satellites from a commercial provider who does not want us to name who it was, but maybe you know. That commercial provider, well, SpaceX. And the interesting thing is it wasn't a very severe event. So we'll play this through a couple times, but what happened is that while they were at 210 kilometers orbit, in their parking orbit before going to their final orbit, this CME happened, That energy heated the upper atmosphere, caused the atmosphere to puff up a little bit, increasing drag, and I think 38 of 40 some satellites wound up re-entering and being lost. So in this visualization, you see a few different components. You see the magnetic field of the Earth in these purple and red lines. The color maps to the intensity of the magnetic field. You see the volumetric is the charge density. And then these little blue streamers map out velocity of particles. So they're just showing the velocity field. The way they're colored, they turn this brighter color when they're headed back towards the sun. So we've now gone behind, and you can see sometimes particles turn around and they're accelerated back towards the sun, back to the Earth. Let's watch that one more time. So the CME is going to happen in a few seconds. There it is. All right, one of the most popular visualizations we do every year is a very simple one. It just shows the moon. We render out a high resolution image of the moon every 10 minutes. Here you see that put together for next year. So this is what our moon will do next year. Played quickly, you can see the phase and libration of the moon. Right, that's why we're actually able to observe 60% of the moon from the Earth because of this libration. You can see it get bigger. This visualization is actually pretty dense. It encapsulates a lot of other pieces of information. So here you see to scale the Earth-Moon system. Along the limb, craters are labeled, but key spots are labeled the entire time. So you see the Apollo missions there in yellow. There's Apollo 11. Anyway, one of the things that NASA just recently released is something called NASA Plus. It's our TV streaming service. And there's a channel on there called Spaced Out. And you can just watch beautiful visualizations with music, and you can space out. And one of the Space Out episodes is on moon phases, and you can watch this very slowly for half an hour if you want. It's not exciting, but it's cool. And yes, it's just slowly coming. Well, we have an eclipse coming up, right? And we had one already, so. This is, of course, the path of the annular eclipse, where you heard a lot if you were here earlier. And this will be the path of the solar eclipse. Hopefully everybody has plans for where they're going to be. I'm going to be here. This map, there's a lot of detail in this map. One of the key thing that makes our map special is this accurate calculation of the shape of the moon's shadow. And that was first done by Ernie Wright, who's a member of the Scientific Visualization Studio. He was able to do it because for the first time with the Lunar Reconnaissance Orbiter, we had a detailed height map. And at the moment of the eclipse, it's the shape of the limb of the moon that matters. In particular, it's where you might think, naively you think, oh, you're just projecting down the shape of the moon, but it's not that simple. It's where the valleys are. And each one of those valleys makes the side of a rough polygon. And of course, that also impacts with the Earth's terrain as well, and that's all been accurately calculated in this map. We also released not just this physical map, but a digital version as well. So on our website, that digital version of the map is available, and that allows you to click on different things. It allows you to click on a city and see what simulated views are going to look like at different times of day. So I encourage you to check that out. And let me just finish with a visualization of the a visualization of how solar eclipses work. And this will be the April 8th solar eclipse, the path it will take. And we're actually viewing things so often in these diagrams because of the challenge of like just physical scale. You often see the scales exaggerated. But here we're showing you the actual proper physical scale and just using some camera tricks to get the right perspective to keep so that you can see everything. But if we pull out, you'll get to see the true physical scale. Let me play that through again. All right, so make your plans now if you have it, and thank you guys very much.